Sir, good afternoon. Sir, welcome, sir. Hari, sir.
Yeah, good afternoon, Girish.
Sir, how are you, sir?
I'm good. How are you?
Yeah, we're doing good, sir. Thank you.
Yeah,
Sir,
thank
we
you.
will start at 4 o'clock. We'll see some participants
Sure. We
joining.
will wait for a few minutes. No problem.
Thank you, sir. Thank you.
Okay.
Sir, Mari sir, hello.
Hi,
Yeah,
yes, good evening.
sir, we'll start the session. Meanwhile, I'll introduce you. Meanwhile, the audience can, the participants can join if any other people are coming.
Sure, sure. Please go ahead.
You?
Yeah.
Yeah. Dear participants, my voice is audible. Make sure that my voice is audible to your text in the chat box so that we can start this session 2 on day 1. Is my voice audible? Can someone confirm it on the chat box? Yes, thank you so much. Yeah. Dear participants of the colleague faculty and other faculties and other professionals, very good evening one and all. Once again, welcome you back to this session 2 on day 1 for the AICTE sponsored training program, 1 week training program on soft computing techniques in civil engineering. Today morning we have received a lecture from IIC Bangalore professor, and today's the expert of this session on day 1, second session is Dr. Mari Swaminathan sir, and I would like to introduce him. Dr. Mari Swaminathan obtained his PE in civil engineering at Government College of Engineering and Technology, Anna University, and later he obtained his master's in transportation engineering at College of Engineering India, Anna University, and obtained his PhD in transportation systems engineering at IIT Bombay. And later he has started his career as research associate and project research scientist during the year 2017 and 18 at IIT Bombay. And later he went to do a postdoctoral research fellowship. He worked as a postdoctoral fellow at SUTT MIT International Design Center, Singapore, during the year 2018, and currently he is working as an assistant professor at National Institute of Technology in the Department of Civil Engineering since 2018 April. Dr. Mani Swaminathan research interests include road safety and accident analysis, traffic engineering and management, pedestrian and driver behavior modeling, facility design and evaluation, traffic operation and simulation, freight demand modeling, and so on. Dr. Mani Swaminathan is also actively involved in various sponsored research and sponsored research projects, as well as the consultancy projects, such as the development of traffic safety evaluation tool using surrogate safety measure, which is approved by NID Trichy, and also road safety audit Madurai Ring Road, which is Tamil Nadu Road Infrastructure Development Corporation, which is completed during the year 2019. Dr. Mani Swaminathan has have a very good number of publications in national and international journals, as well as international conferences and national conferences. Dr. Mani Swaminathan developed a curriculum for PhD students, which is called Transportation Logistics. And adding to that, Dr. Mani Swaminathan also played a crucial role in playing, taking various administration responsibilities at NIT Trichy since 2018. And currently, 2 research scholars are working under the supervision of Dr. Mani Swaminathan, and also he has guided various MTech dissertations and as well as UG projects. So Dr. Mani Swaminathan have a couple of national visits, such as the Singapore University of Technological and Design during the year 2018, and National University of Singapore NUS during the year 2018, and Hong Kong University of Science and Technology during the year 2014, and many more. And most importantly, the TRB annual meeting, Washington DC, during the year 2017. And Dr. Mari Swaminathan also invited for various guest lectures and involved in various workshops and conferences to various institutes, national, international. And Dr. Mani Swaminathan also recognized with a couple of awards, such as he is awarded as for DUO India Faculty Fellowship with Newcastle University, UK, for the year 2020, and awarded for postdoctoral research fellowship from Singapore University of Technology and Design during the year 2018 and 19, and awarded student fellowship from Association of Transportation Professional of Indian Origin in the year 2017, and so on. And apart from this, he is also a reviewer for a couple of journals and conferences, such as a Journal of Traffic Injury Prevention, International Conference on Transportation Planning and Implementation Methodologies for Developing Countries, and International Conference of Transportation Research Group of India, CTRG, and Transportation Letters, the International Journal of Transportation Research, and the well-known Transportation Research Board, TRB, and World Conference on Transportation Research, WCTR, and also the International Conference on Innovative Trends in Civil Engineering for Sustainable Development. With this introduction, I would like to thank and hand over the session to Dr. Mani Swaminathan. Sir, this is fifth time we are collaborating and doing the program. Very thankful to your consistent and continuous support with us for giving and accepting our invitations. Thank you, sir. Please go ahead with your session. Thank you.
Okay. Thank you, Dr. Girish. Am I audible?
Yes, sir. It is very clear, sir, and your PPT is also visible.
Okay. So a very good evening to everyone. In the today afternoon session for your AICTE sponsored STTP, I'm going to cover my presentations under the topic on conventional and soft computing techniques to solve transportation's problem. Let me start with the outline of my today presentation. When it is coming to the transportations problem, we have the various issues. But today presentations, we are mainly going to focus about the planning. So when it is coming to the transportation planning, as a planner, what are the problems we are facing and what is the need to solve that particular problem? Second, what is the four-stage modeling? So when it is coming to the transportation planning, what is the four-stage model and what are the role of that four-stage model that we are going to discuss in the detail in the technical aspect. To achieve that solution for that all the problems, how the conventional and soft computing methods are adopted, that we are going to cover in very quickly. So with a brief introductions about the technical content of the transportation planning and the difference of the conventional and the soft computing methods, how can we apply for one particular object that we are going to see in the detailed manner. Example, if the people are using the motorized two-wheeler, how or whether they are willing to shift to the electric bike or not. Those kind of the mode choice predictions we are going to detailedly discuss in the mathematical as well as the soft computing manner. So this is the brief outline of the presentations. Let me discuss in the detail one by one the section. Start with the transportation planning. So before moving to the planning, we should know the what is the meaning of the system. System, it is a consist of combo pack. It is a combinations of the various set of the components, activities, as well as the entities, how it is organized to move in that given the directions. So for the directions or when it is coming to the sum of the objective, how all the things are connected together and all the things are how it is coming under the one box. So that is considering as a general definition of the system. So when it is coming to the transportation system, so system is connecting everything together in a single road. When it is coming to the transportation, the same meaning it is giving, but in the perspective of the transportation's engineering aspect. Example, how the facilities are provided. The provided facilities, how it is reaching that road users. Finally, how the controlling systems are happening to permit the people or the goods, whatever you want to transfer one place to the another place. So this is the combination of the all the entities in a one flow to achieve our objective, how all the things are mobilized on the field that is considering as a transportation system. So when it is coming to the transportation system, it is a combination of all the aspect. Example, the facilities, how it is provided, how it is reaching that road users or the end user, and all the facilities, how it is controlled to permit the people or goods for transferring one place to the another place. Here, the time as well as the space are playing the major role. So all the things are happening within a time frame without making any delay, as well as all the roads or all the facilities are utilized with respect to the space and time management aspect. So with this respect to the transportation system definitions, so the transportation is playing the major role in the four major aspects. Example, economic. So when it is coming to the Indian economic, so the transportation sector is giving the major contributions. Also, it is giving the input for the social and cultural. Example, if you want to make a one journey, how it is social and cultural wise giving the input for that particular society. Third will be the political. So example, when it is coming to the political, so the best example of how the militaries and are managed with respect to the transport aspect. The final one will be the environmental. So nowadays, the very hot topic is the environmental. So the transportation is giving nearly 13% of the pollution's contributions rate when it is coming to the air. So particularly for the transportation sector. So this is the four major role how the transportation sector as well as the transportation system playing the major role to influence or to affect in the positive as well as the negative manner. So generally, when it is coming to the transportation system, it has a playing the two major role. So one is accessibility. So whatever the facilities you are providing, how it is access to everyone. In India, we have the different kind of the income, different age of the people. To all the people, how the accessibilities are created. So that will be the first generic functions we have to consider when you are planning for the any facilities on the field. Second will be the mobility. When you are providing the facilities, how efficiently it is reaching each other. So that is considering as a second scenario. So to achieve this first and the second one, how the space and the time utilities are happen, and whatever the facilities you have provided, how the quality is maintained, that can be considered as a generic functions. Okay. So this is the first one, how it is accessed for the various land uses. So when it is coming to the Indian roads, we have the different classifications: arterial, subarterial, major road, minor district road, and the village district road. So with respect to the different kind of the roads, how the different access we have provided, as well as when it is coming to the land use. So it might be the industrial or the residential shopping area or the mixed land use pattern. So with respect to the different kind of the land use pattern, how the accessibilities are connected each other, that is considering as a generic functions of the transportation system. The second will be the movement efficiency. So when it is coming to the given road or the bridge or the signalized intersection, with respect to the facilities, how it is efficiently reaching. The second will be the different kind of the mode. You might be having the public transportation, buses, metro, monorail, personalized car. So with respect to the different mode also, how it is efficiently reaching each other when it is coming to the mobility. So this is the two aspects we have to consider when it is coming to the transportation system, particularly when it is coming to the transportation planning. So the planning is nothing but we are examining the potentials of the future action. So what will be the present conditions, okay, with respect to the desired objective or the desired directions, how the potential future actions or the solutions we are providing. So that is considering as a transportation planning. So that is the way we have explained how it is fulfilling the purpose. So we are estimating the present conditions as well as we are generating what will be the future demand based on the present conditions, future demand, what are the transportations plan we can provide. So that is considering as a purpose of transportations planning. So it might be with respect to the safety, comfort, convenient, as well as a smooth movement of the all the traffics. To ensure that need of the facilities or the mobilities, we are giving an actions in the perspective of the transportation planning. So the one examples I used to give the many talks, the accidents are happening. To reduce that accident, not only considering the present conditions, if you are projecting the volume as well as the accident rate for next 30 years, what kind of the facilities we can provide to avoid or reduce that accident, that is considering as a one of the scope of the transportation planning. So with this a brief introductions of the transportation planning, we are facing day-to-day life a lot of issues. So let me throw some of the quick issues. So one will be the lack of the transportation's infrastructure. So what kind of the infrastructures we have provided and what it went wrong manner. So we might be predicted something and we provided the facilities, but whether it is fulfilled the requirement or not, that will be the big question. So understanding the issues, providing the facilities will be the one direct path, but how the provided infrastructures get the fail to fulfill or solve that particular issues, that is leading to the transportations planning issues. Second will be the land allocations. particularly when it is coming to the urban cities, example Hyderabad, Mumbai, Delhi, or Chennai. So whatever the metropolitan cities, if you're taking, so the phase as well as the land allocations plays the major role. Example, if you are deciding to provide the BRTS system, but you have to provide the two lane in the middle of the road for giving that smooth flow of the BRTS. In that particular conditions, the land allocation is playing the major issues. The third one will be the main importance. So whenever it is coming to the Indian condition, the heterogeneity, that means the mixed traffic conditions playing the major role. Particularly when people motorized as well as the non-motorized are mixing each other, that is leading to the vulnerable issues. The fourth will be the no public transport facilities, even though we are provided. So there is a various lags, pros and cons are there when it is coming to the public transport. As well as we have the lack of traffic management and enforcement measures. As we discussed, the accident also one of the main causes, particularly when it is coming to the pedestrian. Then the environmental. So when it is coming to the environmental issues, noise as well as the air pollutions are creating the major problem. The next will be the inadequate right of way. Inadequate right of way we have provided. So this is with respect to the land issues only. So final one will be the how the vehicle ownership as well as the equity what we have provided in the perspective of the mobilities, how it is affecting each other. So that is considering as a major problem. So whatever we have discussed the quick 10 problems, it is a very limited issues I was showing actually. But other than that, we are facing a lot of transportations planning related issues. All the problems can be solved by developing the mathematical equations, or if you are going one step above, when we are developing the soft computing techniques, from that we can able to predict and try to solve that particular issues. So when we are trying to solve the particular issues, so four major points need to be addressed. So it is coming with respect to the efficiency equity. We have to consider the non-motorized facilities. Then we have to integrate the land use with respect to the various transit stations. Finally, the funding is also considerable when it is coming to the transportation planning project. So this is the limited four issues need to be addressed when it is coming to solving all the transportations problem. So with this brief introductions about the transportations planning and the limited problems, I am moving to the four-stage model. So example, if you want to provide some of the facilities in the perspective of the traffic growth and the transportation planning facilities, there the four-stage model is playing the major role. So this is the scenarios. We have the four stage actually. So one will be the trip generations, trip distribution, mode split, and the traffic assignment. So example, how it is playing in the sense, I'm talking about the one individual persons. So example, if you want to start a journey, so this might be your home. From the home, you want to make your journey to the office. So this is a considering as a one trip. So as an individual person, if you want to make a trip, so that is considering as a trip generation. So based on that various requirement, so you are planning to make your trip. So this is for one individual persons. Like that, you can assume some of the city. Example, you can consider the Andhra Pradesh, AP. From that AP, you can consider any one particular city, Vishakhapatnam. So in the Vishakhapatnam, with respect to the people populations, with respect to the vehicle and the people populations, and based on the requirement, how many trips they are making. That kind of the estimations we can make it is in the trip generation stage. So this will be the first conditions. We understand what is the existing conditions, what will be the number of the trips. Second, what we are going in the sense, we are going in the little bit micro level distributions. So your origin might be Vishakhapatnam, but what will be your destinations? It might be the Amaravati or it might be the Hyderabad. So with respect to your distributions or the destinations, how the trips are distributed. So that we are trying to predict in the second stage. Third will be the mode choice. So you might be having the different kind of the mode. Train might be there, car might be there, or the flight might be there. So which mode you are going to choose with respect to the various variable. So that can be developed by the model that is considering as a mode choice model. The final one will be the traffic assignment. So not only the populations or the sample we have considered. So with respect to the whole populations, how the traffics are assigned with respect to the given sample. So that can be assigned and studied in the traffic assignment model. So this is the typical four-stage model when it is coming to the transportation planning. How or the number of the trips are generated, that can be estimated using the trip generation model. How the each trips are distributed based on your destinations, that can be considered and estimated based on the trip distribution model. Third will be the mode choice model based on the various availability, how the modes are distributed. Finally, the traffics, how it is assigned. So when we are studying all these four stage, we come to know how the transportation systems are playing with respect to the existing conditions. Once the existing conditions model is ready, you know what will be the future projections. You can project the traffic volume 30% and you can project the various variables 20 to 30%. Then how all these four stages are changed, that can be estimated. So based on that changes, how the existing facilities are facing issues, to accommodate those growth in the future, how the facilities can be implemented on the field, that can be estimated from this typical four-stage model. So this is the way how the planning, particularly transportation's planning, can be rectified and the problems are solved by following this four-stage model aspect. Here various variables are influencing, so particularly socio-economic variables and the network variables. So as I mentioned that the main motivation is to try to identify and study the trip making behavior by providing or developing the mathematical relationships. So this is the main concept when it is coming to the transportation planning. So we are developing the mathematical relationship based on the existing conditions, as well as you try to give us some scenarios. Based on the scenarios, how it is changing for the future conditions, that can be estimated using this mathematical model. So to develop this mathematical model, we are considering the various variables that can be seen in detail in the further slides. So before discussing about the variables, you should understand how or what different kind of the travel movements are happening. Basically, you consider or assume that this is the blue color shade is considering as a Andhra Pradesh. So the third is considering as a Vijayawada. So this is considering as a Amaravati. Maybe this is considering as a Hyderabad or the some other places. Okay. So when you are making your trip within particular city, that is considering as a intra trip. So when you're traveling to one city to the another city, that travel is considering as a intercity trips. Then the third will be external from your city to, if you are going other city, maybe Tamil Nadu you are traveling, Chennai you are traveling, that is considering as an external trip. The final one will be the transit trip. Maybe you are traveling Chennai to Mumbai by crossing the Andhra Pradesh, that is considering as a transit trip. So these are the different kind of the travel movements we can able to observe and we can study when it is coming to the trip transportations, trip generations. Okay, so different kind of the trips are there: intra, external, as well as the transit. So what is trips? So trips is simply if you're traveling one origin to the destinations, okay, by using any of the transportation mode, including walking as well as the bicycles, that is considering as the trips. So in a days, how many trips are created or the developed by the single persons? And when it is coming to the city, altogether, how many trips they have created? So based on that large scale number, the transportation network system can be evaluated how efficiently it is running to accommodate all these trips. So one example, if you are taking to understand about the trip home, so you are staying in home, what are the possible way we can make it as a trips from home? Example, home to office you may go, or some side work is there, you may go to the work. So home to the work. When it is coming to the weekend or the evening, you may go to the parking or the theater or some entertainment trips you used to make. If the children or the kids are there, they used to go for the school or the colleges, then the playing, as well as the restaurants if you want to make it in the weekend. So these are the possible trips with respect to the individual person from the home. What are the way we can make it as a trips? So like that, we have to estimate when it is coming to the particular city, what are the trips we can identify it. Yeah, as I mentioned that this is an origin and this is then a destinations. Basically, you have the onward journey, origin to the destinations, and the return journey also you have a destination to the origin. Example, home to the office and evening office to home you are returning. So the analysis, everything can be done with the use of the traffic analysis. So the first stage, so in the today presentations, I'm going to give a very quick introduction about the first step traffic or the trip generations. That means that how to estimate the number of the trips. Then the distribution is a simple manner. So directly I'm going to the mode. So how to choose the mode by using the soft computing as well as a mathematical model that we can see in the detailed manner. So before moving to the mode choice behavior model, so let me quickly cover the trip generations. As I told that the trip generation is nothing but we are estimating the number of the trips. So many factors will be there with respect to the factor in that particular city or the particular zone, how many number of trips are or what created. That estimations can be done in the stage of the trip generations. So once we know the number of the trips, from that we can able to project and understand the existing conditions, how well it is accommodated or how poorly it is accommodated based on the given facilities. So with the main application of these things, the trips are generated by activity in a zone can be estimated. So the number of the trips is called as the trip generations. Okay, the trip can be generated, assumed the on journey will be there, at the same time the return journey will be there in that particular zone to zone. So basically the home based trips and the non-home based trips will be there. So example, the home based trips, home to work you are going and you are returning your work to the home. So that is considering as a home based trip. So whatever the trips you are making as the origin of home, that is considering as a home based trips. What does mean by non-home based trips? Example, you are working. So in case in the afternoon, if you want to take your lunch and if you're making to the restaurant or some other shopping, and again, if you're coming back to your workstation, so that is considering as a non-home based trips. So with respect to the origin, with respect to the purpose, the trips are changing and we can give the different classifications. So these are the some of the standard and the selected classifications. So when it is coming to the work based one, education, the personal, business oriented, social activities, and finally recreational. So these are the selected trip purpose. With respect to the trip purpose, we can define how many and what are the trips are made by that particular individuals. When it is coming to the truck, so when it is coming to the movement, there will be the two ways. So one is the passenger movement and another one will be the goods movement. So the main application of the transportations engineering is you are transferring the passenger one place to the another place as well as goods one place to the another place. So these are the scenarios we have studied for the passenger. The same scenarios is followed for the goods also. The four-stage model we can follow for the goods also, but it varies with respect to the different kind of the aspect. Example, the producer, wholesaler, retailer. At the same time, with respect to the commodity, daily product or the monthly product, with respect to the commodity also, the trips are changing. So whatever the way as well as the mathematical soft computing we are following for the individual persons, the same can be adopted and applied for the freight movement with respect to the little variable add-on or the eliminations. So with this brief outline of the trip generations, we have to see what other factors are influencing. Example, whatever the model you are developing, so you might be knowing the mathematical model when you are developing, so independent variable as well as the dependent variable will be there, okay? So basically what we are doing in the sense, we are trying to predict your dependent variable by considering variable independent variables. So for estimating this dependent variable, we should know what are the independent variable can be included in that particular model. So when it is coming to the transportation planning, particularly car or the vehicle passenger or transferring the passenger one place to another place. So these are the factors are playing the major role. So all these factors should be considered when it is coming to the transportation planning. Example, different kind of the land use characteristics, demographic informations, exponential growth rate in the perspective of the economic as well as the vehicle growth. And when it is coming to the growth rate, we need to see how the gender, age, and all influenced. In parallel, we have to see how many trips are made it by in a day, what are the modes are utilized, example public transportations or the private transportations, what will be the trip rates in particular city, what are the trip purpose are there. We have discussed different trip purpose, how it is distributed, and what will be the travel time based on your origin and the destinations, as well as in case if you're studying about the goods, what are the truck trip informations we can include as an independent variable, and all other possible variable also we can include on it. So these are the quick view about the factors which can be considered as an independent variable when it is coming to modeling, particularly four-stage modeling. So this is one step micro level we are going. So when you're talking about the one individual person's example, you assume yourself, if you want to make us a trip, okay, by adopting one particular travel mode, example, car or the bus, what are the factors are influencing? Example, income. Our income are playing the major role. If you are in the high income people, you used to prefer by your own vehicle for saving your travel time. And the car ownership, home, whether you have the car or the two-wheeler, or if you don't have nothing, so the ownership, vehicle ownership is playing the major role. Then the family size and the compositions, so both people are working, both are working in the same office, or if you want to drop your kids in the school and you are going for your job, so how the family size and the compositions are creating the influencing on your transportation planning model. Then the land use characteristics, where you are staying and where you are traveling. Example, you are staying in the residential area and you are traveling towards the institutional area or the industrial area. How distance from your city, accessibility with respect to the public transport, employment opportunities, and some other factors. So these are the one individual persons. If you want to make your trip, what are the possible factors? These are the some of the selected factors. Other than that, we have the various factors, how it is influencing to make your journey from your origin to destination, as well as how it is influencing to choose your travel mode, whether the car or the bus or the two-wheeler. So once we understand all the input parameters, what are the factors we can consider and what is our main objective, then we can move for the various mathematical as well as the various soft computing techniques. Example, when we are talking about the trip generations, as I told that here we are estimating what will be the total number of trips. So this is nothing but a continuous variable. Okay, so this is nothing but the variables. It might be the 9 trips or the 10 trips. Example, if you want to develop the model for the weekly trips in that particular city, so what will be the total number of the trips that can be estimated as a number. So basically, if you're going at the little bit the micro level, the study can be explained with respect to the attractions with respect to the productions. So here basically we are assuming that if you're making a trip origin to the destinations, then if you're backing your return journey to your destination to the origin. So when it is coming to the individual, it is fine. When it is coming to the whole system, how the trips are created with respect to the all the micro level segregated zone in that particular city. So that is the way we have explained the distributed before the distributions. When it is coming to the generations, the generated values are equal to the attractions. With respect to this basic assumptions, by considering the basics or various influencing variable, we can develop the model for estimating that continuous variable, which is nothing but your total number of the trips. So once you estimated maybe the 1,500 trips are created in that particular city, and it has a 4 different zone. So how this 1,500 is distributed? Zone 1 to zone 2, 3, 4. So like that, the distributions can be estimated when it is coming to the trip distribution. That means your second stage. So I'm not going to cover in that particular second stage, but when it is coming to the trip generation, so these are the some of the mathematical model we can estimate as well as we can generate for calculating the number of the trips in that particular city. So most widely they used to use the technique as a linear regressions analysis. So here we are assuming the various basic assumptions. By following that assumptions and your data, if it is for the normal distributions, then we are trying to adopt the linear regressions. It might be the simple or the multiple linear, but it with respect to the your independent variable, how many factors are influencing. So according to that, we can develop that model. In case your data is not falling in that particular normal distributions, or if it is falling under the non-parametric distribution, what are the other ways to develop the model? So these are the some of the non-collinear regressions analysis, and you can transfer your data in respect to the different form. According to that, you try to identify what distributions exactly it is fitting for the particular data. Then you try to adopt that particular modeling aspect. So example, we try to adopt the reciprocal transformations. You can check the exponential functions as well as the semi-log arithmetic transformations. Power functions also you can do, and we can doubling and the tripling. So you just increase the power functions and how the transformations are happen. With respect to the log transformation also, how it has happened, that we can estimate it. Finally, we try to identify and apply the cross classifications analysis also for estimating the trip generations. So these are the some of the mathematical model we try to adopt for estimating the trip generations. But when it is coming to the soft computing, we try to adopt the ANN techniques or the fuzzy techniques also we can try to adopt for estimating that number of the trips. So this will be the very overview if I'm giving with respect to the theoretical approach. So when I'm explaining with respect to some of the example, definitely you will get in a clear pictures how it is varying for the mathematical as well as the soft computing techniques. So before moving that case study or the practical example, I will give very quick details about the mode choice. So what is mean by mode choice? So you might be having the different options or the different alternatives. Among that, which one you are going to choose? So that is considering as a mode choice or the selections of the alternatives. So it might be varying with respect to the different attributes or the characteristics with respect to the individual persons, or when it is coming to the city together, how the cumulated attributes are influencing when it is coming to the mode choice behavior. So as I told that the distributions, once the trip generation is over, so you might be knowing the distributions, what will be your origin and what will be your destination. To make this particular trip, what are the travel modes are available? So you have to see what are the available transport mode, and you might be seeing the individual person's responsibility or the factors of the individual persons. Based on that, what mode that particular person is choosing, that can be estimated in the mode choice model. Basically, when it is coming to this mode choice or the split reference, they used to refer the private car as opposed to the public transport. So basically, they used to refer as a threshold line as a public transport, how it is varying with respect to the private car and the other facilities, or they can take it as a private car as a threshold, how it is varying. That fractions can be estimated. From that, the mode split can be calculated. So this is the main things what we are following in the mode choice model. So when it is coming to the mode choice model, so this is why you might be choosing car for your journey, yes or no. This can be estimated as a your mode choice behavior. Okay, in the mode choice, why you have to identify what are the significant variables. So basically, the mode split model has three major contributing factors. One is the socio-economic characteristics of the individual person. Second will be the trip characteristics. So what is the trip purpose or the travel distance? So other characteristics are influencing. Finally, the available mode, what will be the existing mode? With you, cycle is there, then the public transportation is there. So with respect to the existing available mode, as well as what are the alternatives you can able to choose. So considering all these three pillars, how we can estimate the probability of that particular person, whether he is choosing the car or not. So this kind of the estimations can be done by developing the mode split model. And these are the same factors, how it is influencing each other. Basically, the data can be collected in the two ways. One is the revealed preference, another one will be the stated preference. Quickly, I will give the view about the revealed preference and the stated preference. Example, you want to make the journey from your home to office. Okay, so this is your origin and this is your destinations. You might be having the two options. One is car. In case if you are following the car, it is taking the 40 minutes. Then the public transportation, train is there. If you're choosing train, it takes a 30 minutes. And which one you are going to choose? That actual behavior we are asking that particular person, and he is replying as a car, he is choosing as a his transportation mode. So this is considering as a revealed preference. So example, you might be knowing your journey. With respect to the journey, what are the existing modes are available, whether what mode you are following, or with respect to the existing mode, what mode you prefer by considering the various constraint. So that can be estimated or the perceptions predicted from the revealed preference survey. The same stated preference. Stated preference, what we are doing in the same scenarios will be there. In that same scenario, you are telling that if you're traveling by the train, it is taking 30 minutes. If you're traveling by car, it is taking 40 minutes. In case if you're providing the new service, example, in case if you're providing the metro rail, it is coming under the 20 minutes. So the question is whether will you choose that or will you shift to that new service or not. That can be predicted from your stated preference survey. So this is the two way we can collect the data with respect to the mode choice, revealed preference and the stated preference. And this is the difference how the two data are replicating in the form of the data. So now we can move to the model development. In the second scenario or the second part of the presentations, I will give a theoretical approach, a very quick theoretical approach. If I'm giving the little in the detailed manner, it will go in the mathematical core aspect. So I will give the glimpse how the model can be developed using the various mathematical model as well as the soft computing. The theoretical approach, I will give an overview, and with respect to the one example of the collected data, how these two aspects can be compared to finding that best or the suitable model for that particular problem. So here, the model aspect, everything I'm going to explain in the aspect of the mode choice model. Example, two kind of the objective. So if you want to travel origin to destination, whether you choose car or not. So that will be the one aspect. Second will be there, you might be having some of the vehicle. Example, you are traveling in the two-wheeler, whether you are willing to shift public transport or not. Okay, those two kind of the behavior how we are observing. So in the today presentations, I'm little narrow down our presentation as a binary data. So example 0 or 1. So 0 is indicating that you are choosing or not choose, example not choosing car. 1 is indicating the choosing a car. Example 0 is indicating that you are not shifting to the public transportation and you are shifting to the public transportations. It is a binary data, binary kind of the predictions, how can be done using the mathematical as well as the soft computing that we are going to see in the little detailed manner. So it is a discrete data, as I told that it is a discrete data, and the different kind of the models are available for developing the discrete model. Particularly here, the probability of distributions are playing the major role. So when it is coming to the individual or the aggregated, how the probabilities are playing the major role by considering the various parameters. So those kind of the probability distributions and the estimations can be estimated using the discrete choice model. So basically, discrete choice model has a different aspect: discriminant analysis, probit analysis, and the logic analysis. So discriminant, so analysis when it is coming to the non-parametric data, how the data are segregated, maybe how the learning of the data followed for the developing the model. So little bit the micro level analysis can be done. So the second will be the probit analysis. So how the probability as well as when it is coming to the different kind of the scaling, how equally or the different weightage can be distributed for estimating that given probability distributions of your y value. Then the logic analysis is changing with respect to the number of choices. As I mentioned that the one example is 0 or 1 that can be estimated in the binary logic model. So like that, the different choices are there, maybe more than two choices are there, how the logic or the probit model can be adapted. Example, you might be aware the term level of service. It can be varies from A to F. It has a 6 category. So for estimating that the 6 categorical data, how the models can be developed. So that is also coming under the probit or the logic or the cumulative logistic regressions. The next one will be the hierarchical or nested logic model. So nested logic model, it is a connected each other. So example, if you want to make your journey, so you might be having an options of the public transportation and the personal options. So when it is coming to the personal, you might be having the car and the two-wheeler. So it has a different stage. Even public also, you might be having the bus and metro facilities will be there. So it is in a layer, stage by stage, in the two stage and the nested. So when it is coming to the journey with respect to the two classifications, how the probabilities are distributed. Example, the probability varies from 0 to 1. So when it is coming to the probability 0 to 4 and 0 to 6. So when it is coming to the 0 to 0.6 probability, how it is distributed, okay, 0.8 and 0.2. So when it is coming to the journey, the person is choosing the personal car, a personal, when it is coming to the personal vehicle, he is choosing the car as a high probability. So this kind of the nested distributions we can estimate by using the hierarchical order or the nested logic model. So these are the mathematical, some of the discrete choice model can be adopted for your transportation's mode choice behavior model development. And the main concept here using is the concepts of utility. So utility theory here, it is playing the major role. So when it is coming to the utilities, how the traveler preference are given for the particular mode or the combinations of the different modes, how it is varies with respect to the different attributes. So you might be having the different attributes, how it is varying. So considering that all the attributes, how the utilities functions can be developed. So that is the main playing the major role. So example, everybody might be other than the binary logic model. So during our last STTP, we have seen how the binary logic model can be developed in the SPSS software. So this is our basic utility functions. So the utility functions and x1, x2, your different kind of the attribute, okay, till xn it will be there. And using that utility functions by adopting a log likelihood or maximum likelihood method, so you try to estimate what are the estimate value for this a1, a2, a0, as well as you try to estimate the error term also. So this is the concept of the utility functions can be developed using your independent variable and the dependent variable before applying your probability model. So before discussing the probability model, I will just give the overview how the evaluations of utility functions can be happen. So here the mode specific of the utility first can be understand. So once you understand the mode specific utility, you try to identify how the attributes are utilized for the single or the individual mode as well as the combinations of the mode. So finally, the total utility can be considered. Okay, once you understand the utilities, so the total utilities are how it is varying with respect to all the specified attributes that can be estimated. Then with respect to the socioeconomic characteristics into the total utilities, because when it is coming to the trip, the socioeconomic characteristic is playing the major role. So the finally, all the factors can be considered, particularly socioeconomic characteristics, but still it giving the lagging because we are trying to predict the human choice. So it is fluctuating, it is varying. So to understand that fluctuations and the variations, you have to incorporate your behavior theory also. So once you are incorporating all these theories as well as the utilities, so then it can be applied for your probability equations. So that can be explained here how it is different for that each individual. Example, you consider the one factor as a income. Okay, so the income you have calculated the average. So the average does not mean that it is the middle income. So basically you have the low income, middle income and a high income. So it does not mean that the average is indicating the middle income people. So those kind of the assumptions and the variations are there. So how the mean and the deviations are varying with respect to the individual parameter, as well as by considering the logical behavior theories of the each parameters, then the models can incorporate the particular variables considering or developing that utility concept in the utility functions. So this is with respect to the generalized factors. So how it can be incorporated. So IJ, it is with variance with respect to the number of attribute as well as the number of the factors. This is the utility functions. Basically, we used to call as the utility functions. See here you have the random part. Okay, how the difference between the observed and the predictor can be normalized by introducing the random part or the error term. So many of them familiar how the error term can be estimated. So here I'm not going to cover in the much detail. So with respect to the two travelers patterns, U1, U2 can be estimated with respect to the behavior of V1 and V2 based on the predictions as well as the field conditions, how the changes are happened, that can be estimated. So like that the two persons difference can be estimated. So this is with respect to the two alternatives with respect to the traveler, but with respect to the different alternatives how it is varying, that can be estimated from the different kind of the distributions. Then it is coming to the transportations planning. We used to follow the Gumbel distributions. In the Gumbel distributions, so this is the way. So example, the binary logic, everybody is familiar. So your threshold will be there as a 0.5. How the variations are happened below 0.5 and the above 0.5. So two traveler options are there with respect to the V2 and V1. The priority is more for the V1, how it is varying, and the priority is for the V2, the plot is varying with respect to that positive as well as the negative manner. So with respect to the Gumbel distribution, we can estimate, example, you consider as a 200 data points. The 100 point is falling under the blue line and the 100 point is falling under the red line. Okay. So this is the way how they are estimated that, okay, term is a random utility term. So like that, we can estimate for the all the points, the finally the cumulative value can be incorporated in the developed model to reduce that uncertainty of your developed model. So this is a simple example. So two options are there. So one is taking as a 40 percentage. So definitely the alternative is taking as a 60 percentage. So 40-60 can be divided and the probability of choosing that first alternative can be estimated with respect to the 40 percentage. So like that, when it is coming to the second options, that can be estimated with respect to the 40 plus 60. So this is the way we can estimate for the probability of choosing option 1 and probability of choosing options 2. So like that, you might be having the n number of the options. So how the utility can be distributed for estimating the individual probability of choosing that particular facilities. So this is the generalized equations for the binary logic model, how we can estimate that probability distributions. So far we have quickly discussed about the different mathematical aspect when it is coming to the discrete choice model, particularly mode shift model, how the logic models we can adopt in the logic model, how the utility functions as well as the uncertainty terms are playing the major role, and how theoretically it can be estimated, that I have given in a quick view. So next we will move to the soft computing techniques. So what is the application of the soft computing techniques? Basically, it does not mean that your data has to follow some particular distributions. So particularly when it is coming to the transportation planning issues and all, we used to follow or we used to assume what kind of the data you are following in the distributions. Based on the distributions of your dependent variable, what kind of the model we can develop. So this is the way we have to project our model, as well as the number of the data. Since we are playing with the real world data, so each model has a constraint of the number of the sample. So in case your data is not fulfilling the sample size test, what will be the alternative options? The third will be there. You might be practically justifying that one factor is highly influencing that particular dependent variable. But when we are trying to perform the mathematical evidence, it failed to provide that significant role. In that particular cases, as a transportation planner, I must understand that the factors must need to be incorporated in your final model. Still, if you don't have the statistical evidence, what will be the solution to incorporate it? So these are the some of the three highlighted problems when it is coming to the mathematical aspect, particularly the error term also creating an issues in the mathematical modeling. So to solve that all the issues, we can adopt the soft computing techniques. So when it is coming to the soft computing techniques, it is nothing but your machine learning or your data mining techniques. How the data mining or the machine learning techniques can be adopted to overcome various drawbacks can be observed in the mathematical applications or the aspects. So basically, as I told that here, it is a supervised learning. So you might be giving an input and the system is assuming the different aspect based on the input, it generating the output. Again, it is over generating and the data are overlapping. So it is a kind of the learning and the training process are happening with respect to the given data. So without falling or without assuming any probability theory or any distributions theory. So with respect to that, it's trying to produce that particular output which can fit and which can incorporate all feasible and the possible parameters. So basically when it is coming to the supervised learning, so the data is inferred functions. So the mapping are happening for the each and every iterations and it is giving the classifications for the each problems. Finally, it is trying to produce the optimal solutions for the particular issues which can be fit for the reasonable solutions for the particular problems. So in the today presentations, I'm giving very quick overview about the support vector machines and the artificial neural network in mode choice analysis. So I will give the theoretical view very quickly how the SVM and the ANN can be adopted. Particularly, we can see in the result how the choice of the motorized two-wheeler to electrical two-wheeler is varying. So when it is coming to the support vector machines, it is a hyperplane which is segregating or classifying your data. So here I am going to explain with respect to the two probabilities, 0 or 1. So when you are plotting your, this might be the 1 or this might be the 0, you assume that how the hyperplane is segregating your data in the two directions. So that can be estimated and analyzed using the support vector machines. So it is a binary classifier. It can classify more than the binary data, but here I'm explaining with the binary classifier how the hyperplane is maximizing the margin between the two classifications. Okay, so it can be solving for the multi-purpose also that can be estimated here. So basically, different kind of the classifications functions are there in the support vector machines. So generally we used to refer as a kernel SVM, how it is efficiently performing for the non-linear data, particularly when it is coming to the mode choice behavior. As I told that here, different kind of the factors as well as the behavior mode also playing the major role. So with respect to the kernel tricks, with respect to the different 3D space, how we can fit our data or overfit the data when it is coming to the non-linear kernels. Based on that, how the threshold can be defined to segregate your data as a 0 or 1. So that can be followed. So this is the way the kernels has the three classifications. So whatever the model and the classifications which I'm giving a overview, it is based on the OR software. So here we used to follow the OR software. It is an open source and it is easy to learn. So wherever you are getting an issues, you have the various platform to rectify your issues. So based on that experience of our software, so we used to follow the three classifications: Gaussian, kernel, sigmoid, and polynomial. So these three classifications of analysis can be done when it is coming to the SVM, and all these models can be differed or explained with respect to the difference of the mathematical approaches. Example, when it is coming to Gaussian, so there is no prior knowledge about the data is procured for adopting this particular data. So it is solely performed with respect to the your independent variable as well as your standard deviations. So when it is coming to the sigmoid, so most of the linear data, particularly when it is coming to the discrete data, so we can adopt this particular model and it can provide the best solutions. So here the tangent, hyperbolic tangent relationships, it is assuming based on that relationships, the layers can be formed. Based on that layers, we can try to extract the your final outcome. Then the third will be the polynomial, the kernel. So the term itself, you can able to understand the polynomial relationships can be make it as a simplest kernel functions here. Based on that polynomial power, what you are assuming, according to that, the solutions can be adopted. So basically when it is coming to the SVM, so different kind of the kernel functions are there. And when it is coming to the mode choice model, we use or most widely we used to refer all these three kernel functions and comparing these three kernel functions, what will be the best solutions it is providing that can be given as a final solutions. The next artificial neural network, I'm damn sure everybody is aware about the ANN. So it is a training with data with respect to the different kind of the layers. So based on the layers, how the combinations are, how the signals are transmitting each other, the final, you might be having the different kind of the inputs in the different kind of the format. The final outcome, how you are getting, example, different memberships or the different variations of your data will be there. So how the single input or the desired output if you're getting by training your data by adopting various algorithm and the mathematical approaches beyond the limit of the ANN concept. Okay. So I'm not going to cover much in the ANN concept. I hope you have attended the many sessions in the ANN. So you might be knowing what will be the input and output. So two input and output layer will be there and the hidden layer will be there. In the hidden layer, all the process can be performed. Okay, so here all the process are following. So once the all the evaluationary and the machines and the data are trained, so you try to get your desired output. So this is a three layers: input, hidden, and output layers we are giving. So based on that, we are getting in your output. So this is the main things when it is coming to the ANN, particularly when it is coming to the mode choice modeling and all, we try to adopt three kind of the activations functions in ANN: rectifier, sigmoid, and hyperbolic tangent. So with respect to the three functions, how it is varying, how the accuracy can be improved for your particular data. According to that, we finalize your model. So some model you will get in a sigmoid as a best function, or some model you may get in the rectifier. So by adopting and comparing various factors or the analyzing goodness of fit measures, we will finalize which activations functions can be given as a final solutions. So like SVM only, all these three methods are varying with respect to the different kind of the mathematical explanations. So when it is coming to the rectifier, we used to refer as a ReLU. Okay, ReLU is the most widely used activations method in the neural network. Here the weight of the hidden layers are assumed like that. Okay, 0 and 1. So as I told that here I'm considering the two parameters 0 or 1. So with respect to the basic assumptions, how we are giving the weightage for the hidden layer to get the desired output layers. Then the sigmoid functions. So here the nonlinear activations functions we are considering as the logistic activations functions. So according to that, your variables are changing. Our mathematical explanations are changing how the logistic activations can be incorporated in your model. Okay. Then the final one will be the hyperbolic. So other than that, we have the different kind of the functions. But in our research, we used to adopt and we used to compare this three kind of the activations functions. So here the direct term is the hyperbolic tangent function is assumed, and this is the way they are explaining how the activations functions can be explained in the hidden layer to get your output. So this is the generalized overview about two selected soft computing techniques. Okay, how your SVM support vector machines, artificial neural network can be adapted for your mode choice behavior model. Under the SVM, we have the different kind of the kernel function kernel. So what are the kernel functions can be adapted and compared, particularly when it is coming to the activations functions of the ANN, which we used to refer the mode choice models. The three major activations functions can be overviewed in the previous slides, and this is giving an overview of the modeling. So many of them familiar with respect to the modeling aspect. Still, I will give the quick view about the modeling. So basically, as I told that when it is coming to the mode choice, you are trying to collect the stated preference as well as the revealed preference data with respect to your objective. So once you collected the data, you have to do the data cleaning and the data coding process. So in the data cleaning, you're trying to eliminate what are the duplicates data are there, and you try to perform the outlier test to eliminate the non-required samples. Then you're trying to perform the correlation test, preliminary statistical test, okay, discrete statistic analysis, correlation test, and before moving to the model, you try to find what is the distributions of your data is falling. So studying, understanding, and predicting the type of distributions of your data is one of the main field in the modeling aspect. So once you know the distributions, according to that, you try to develop your model. Particularly when it is coming to the mode choice, utility function is playing the major role. So you try to develop any logic model as well as you try to adopt any of the soft computing techniques. Then the model calibrations as well as the validations. Okay, so when it is coming to the evaluations, the major term which we are using is the R squared value. So the R squared value is considering as a main parameters to evaluate the reliability of your developed model. So not only R squared, so many other parameters also there. Example, success prediction table, ROC curve is there. Okay, other than that, map value, RMS value. So different kind of the parameters are there. All the parameters are estimated using your developed model. Based on that, you try to finalize what will be the best model for your given data. So basically, this is the two major goodness of fit measures. One is your R squared. When it is coming to the logic model, McFadden pseudo R squared, then the ROC curve, operating characteristics curve, which can be plotted. From the graph, you try to identify what will be your area under curve. Okay, so what is the AUC value? So basically, it is considering as a Gini coefficient. It varies from 0 to control 100. How the variations are happened. So the highest number is giving the best solution. So this is the two parameters we can consider for the overall evaluations, but it is not limited. Other than that, we try to develop and adapt the various measures. So this is the way how it can be given as a ROC curve. So we try to estimate how maximum the values are covering by using your developed models. So these are the some of the selected advantage. So when you don't have the large data, so how it can be used. So that will be the biggest questions that can be done in the soft computing techniques. So the algorithm is training by their own. So the accuracy and the efficiency level definitely better than the mathematical model as well as the assumption. So these are the two selected advantage. Other than that, it has so many advantages. Then the disadvantages, it is mainly it is requiring the massive data to train the data. So when it is coming to the data set, the training data itself, it takes on a huge part. So that will be the slightly complications, and it is a time consuming and depending upon the algorithm and the modifications, if it is in a simple problem, it is fine. But when it is coming to the multi-objective functions, so how the modifications can be followed and how the time consuming for performing this analysis, that will be the complex task, and it need the additional requirement. So when it is coming to the simple mathematical model, the sources and the availability of the resources and the adoption is slightly easy, but when it is coming to the soft computing, it is require the different kind of this resource supports, or example we can say the software requirement, how can we adopt for applying that soft computing techniques. So these are the some of the selected objectives. So while I circulate the PPT, you try to capture other disadvantages as well as the advantages, and this is the comparisons whatever so far we discussed, that quickly I have described in this particular table. So far we have discussed the very brief introductions about the transportation planning problems, the mathematical as well as the soft computing techniques. Here I'm going to give a one objective, one specific objective, how the mathematical as well as the soft computing adopted. So the main objective is, as I told, that motorized two-wheeler will be there. By performing the various questionnaire form, we try to capture whether the people are willing to shift e-bike or not. So 0 or 1. 0 means people are, example, considering as a not willing, and 1 means people are willing to shift. So this kind of the mode shift behavior we are trying to predict in your model. So here I will show the results of the two models. One is the mathematical model, binary logic model. Then the same objective can be achieved using SVM as well as the ANN model. Okay, so basically the concept, the logic, everything is same. So this will be your y dependent variable, and you might be having different kind of the independent variable. By developing the utility function, you come to know how the binary logics are developed. Then you try to capture what will be the R square. From that, you try to fix how efficiently the developed binary logic model is performing. Like that, SVM and ANN, 3 activation functions and 3 kernel functions are there. All these 3 functions are how it can be developed and what will be the ROC value for all these 6 methods. So out of all these 6 ROC, we can plot for your binary logic model also. Out of this 7, which one is performing the best one, that can be considered as your final proposed model to predict the mode shifting behavior from motorized two-wheeler to the electrical bike. So this is the overview of the methodology which we adopted in this particular objective. And these are the different kind of the factors we have collected from our questionnaire form. So these are the XI. So we conducted the online survey, and this is the survey form. So hopefully many of them aware of the particular form since we have circulated in the last STTP, but still it is okay, fine, it is not needed. And 4 different state data were collected: Maharashtra, Andhra, Karnataka, Tamil Nadu. Online questionnaire form has been collected. 537 samples were collected. The first step told that the data coding, then the data cleaning, and the outlier test also we have performed. Out of 537, 522 data were considered for the model development. Okay, so the main motivation is to predict the mode shift from the motorized two-wheeler to the electric bike. And these are the generalized descriptive analysis. I'm skipping all this analysis. So directly I'm moving to the model. So basically, so this is the data we have collected. Out of 522, 406 people are rated they are willing to shift their mode as an electrical bike, and 116 people are not willing to shift for the electrical bike. So this is the way we are trying to predict 1, 0, how your probabilities are distributed. Okay, so this will be the 0.5. So this estimations can be done by developing your binary logic model. So as I told that before moving to the model, you try to identify what is your significant variable. You might be having the plenty of independent variable. Out of that, which one will be the significant, that can be done using the correlation test. Example, Pearson's correlation, Kendall's Tabo methods, Spearman's. Here the two methods are there, and from that model analysis you will get the significant value. One star is indicating 95% confidence interval. Okay, so here three parameters, it is indicating that significant variable for developing the model, and this is your final binary logic model. So this is then a model outcome, existing mode, distance travel, significant factors. So here you have to check your vault value. If it is 95%, it's supposed to be greater than the value. And when it is coming to the sign value, it's supposed to be less than 0.05. So then it is significantly influencing. So using this this might be considering as a beta 1, your coefficient 1, coefficient 2, coefficient 3, and this will be x1, x2, x3, and this will be constant c. So if you're adding plus and this will be the minus value, so this will be your utility functions. So using that utility functions, you can able to estimate what will be your future scenario. And as I told that here, this is developed in a piece of software. That is the reasons we are getting the R squared value negliger and Cox and Snell R squared, and the value is low 0.32. Everybody is aware that R squared 0 to 1. So when it is approaching near to the 1, it is considering as a best fit. So here 0.32, but the classification table is indicating the 82.4. The major issue is that the performance analyzed with respect to the calibration data, not with respect to the validation data. So that is the reasons it is showing the high value, but the R squared value is very less. So this is the way we can get an output of the binary logic model. You can develop the utility functions and you compare your goodness of fit measures. And this is the way how we can compare after binary logic model. So this is the ROC curve is indicating, the blue color line is indicating the ROC value for the binary logic model. So it is showing the less than 0.5. So the reference line we have plotted with respect to the 45-degree. So it is showing that less than 0.5. Same. Likewise, we try to follow the three model. One is the hyperbolic tangent in ANN, Rayleigh method, and the sigmoidal method. All these three methods we have performed in the R squared, and we have estimated that ROC value for all these three. Out of all these three activations functions, Rayleigh function is giving the best fit. So this is the way I have explained when it is coming to the theoretical approach, because Rayleigh is the most widely used method, particularly when it is coming to the binary data. So it is giving the best fit. So this is the outcome we can get it from the ANN Rayleigh method. The next one will be the SVM. So SVM I have explained with respect to the polynomial as well as the sigmoidal, other than RBF, and other than that linear also we try to capture. When we are trying to plot the ROC curve, SVM sigmoidal. So SVM sigmoidal is giving the higher ROC value. So the area under the curve is giving the highest value out of all these four kernel functions. So when we are trying to compare BL, binary logic model, we are getting less than 0.5. When it is coming to the ANN, Rayleigh method we are getting, so that is more than 0.5. It is coming around 0.75. So ANN Rayleigh method is giving the best one, that is 0.75. But when it is comparing with respect to the SVM sigmoidal, so it is coming under nearly 0.9. So SVM kernel, particularly SVM sigmoidal, it is giving the 0.9. So to compare all these three methods, so SVM is producing the best solutions with respect to the ROC value. So we conclude that when you are trying to develop the model of your user choice or the willingness to shift motorized vehicle to the electrical bike, SVM sigmoidal model is producing the relatively higher accurate result for your particular objective. So this is the way how the result can be extracted from your R software and how the parameters can be compared for finalizing your result or the model approach to achieve your particular objective. So here I am concluding the final conclusions. We have discussed about the transportation's problems and what are the solutions can be directed with respect to the achievement of that particular issues. And we try to capture and understand the influencing factors, particularly when it is coming to the four-stage model. In the four-stage model, we have seen the very quick view about the trip generations model. Then very detailed manner we have discussed about the mode choice model development and what are the factors are influencing in that mode choice model. Finally, theoretically, we have seen how the mathematical expressions can be given for your conventional method and soft computing method. Particularly, we have seen about the logic discrete choice if it is there, how the mathematical binary logic as well as the utility functions are developed by adopting that utility functions or utility theory. Then we have seen two soft computing method overview, ANN and the SVM, different kind of the kernel and the activation functions. And from the collected field data, one objective, which means the mode shifting from motorized two-wheeler to the electrical bike, how the binary logic model result looks as well as the SVM and the ANN result looks. From that outcome, based on the different kind of the goodness of fit measure, how we can conclude one as the best solutions or the best method for the future predictions for your study or the research objective, that we can see in the quick manner. So this is the macro level conclusions. What are the things we have covered in our today presentations? With these conclusions, I would like to thank AICTE for sponsoring this particular workshop, particularly Sri Vishnu Engineering College for providing these opportunities. Okay, particularly the head of the department, Dr. Girish, for giving that opportunities. Consequently, we are collaborating for the sixth time, and thank you for your opportunity. And I would like to thank all the participants. Stay safe and stay home. So now the floor is open for the discussions. So I'm handing over the session to the organizer.
Thank you, sir. Thank you so much for your wonderful session.
Yeah.
I hope the participants came to know a lot of application of this soft computing techniques in transportation. So yeah, this is a discussion part now. I request the participants to kindly post your questions in the chat box so that the speaker can address your questions.
Since it is an overview presentations, I have given an overview, not in the detailed manner, not in the detailed manner. So when it is coming to the So the question is, what changes you anticipate post COVID-19 on transportations? Yes, definitely the transportation experts are working on that particular directions, how the impact are going to happen in the transportation system. The first slide itself, I have defined the transportation system. So definitely due to the COVID impact, the transportation system slightly going to change. That prediction is going to, many researchers already started in India, how the number of trips can be reduced. So that kind of the estimations, because with respect to the different kind of the modes, so there can be a two kind of the thought is going on. The people are trying to encourage the personal vehicle instead of the public transportation to avoid the COVID impact or the spread of the coronavirus. So when you're trying to shift to the more number of the personal vehicle, obviously the traffic and the flow and the populations of the traffic increase on the particular road network, which ultimately leads to the various issues like a delay, congestions and all. So that will be the one of the possible, what we can say, issues with respect to the COVID-19 on the transportation system. So like that, we have in the many directions. So can you suggest any course to improve our skills in this area? So the question is very general in this area, in the sense here two areas are there. Three areas are there. If you're going in the micro level, one is the transportation planning. So definitely NPTEL courses are there. The second will be the mathematical. So when it is coming to the transportations and the modeling and all, so you have to be thorough in mathematical. So wherever I'm giving the webinar, particularly when it is coming to the traffic and the planning, I used to encourage the people to strengthen your knowledge in mathematics. So particularly when it is coming to the mathematics, probabilistic and statistics are playing the major role. Even though forget about the probability, statistic is playing the major role, and you can try to able to study so many online courses in the statistics. Third will be the soft computing. So directly you won't get a soft computing techniques. Okay. So if you're getting a course also, that will be in a very overview. But instead of that, you try to choose any one of the method. Example ANN. So ANN for the beginner and the medium level, middle level are also different kind of the levels. So they have classified the course online materials. So that also you can cover it. So in this three aspect, if you're exploring, so definitely you will get a good knowledge in that particular area. So the next question. So the preference for public transport had taken a hit due to the post-lockdown. How can we address these issues? So yes, definitely it will give the negative impact for the public transportations due to the overcrowding. But still, so India has the different kind of the income level of the people. Still, the people are preferring the public transportations. The considerable amount of the reductions are happened, but still it is happening, and it is expecting to happen in the future also. To address that issues, the government has to come up with some of the policies. Example, the sanitations. Okay, before starting that journey, the buses completely has to be sanitized and sanitized. Oh, and properly, it supposed to be properly. It can be monitored. Okay, so those different kind of the policies you have to bring with respect to encouraging the public transportations. So that can be one of the way we can address that particular issues. Dr. Girish, am I audible?
Sir, you are audible, sir. Yes, yes, please go ahead.
Okay, okay. So this is the one way. So you have to try to identify the various policies to encourage the public transportations, okay, to avoid the impact of the COVID-19. So sanitizer, and you have to encourage the distance between the passengers. Maybe you have to give the contactless ticket. There is no need of the conductor. Okay, directly they can get the ticket from the any app with respect to the vehicle number. So those kind of the smart based solutions if you are providing, and how much we are reducing the contact between the each other, so that definitely will encourage the people to use the public transportations. Even you try to reduce the fare. If you are reducing the particular percentage of the travel fare or the bus fare, then the people may attract towards the public transportation. So all the policies analysis can be performed to address that issues. Did you study on transportations regarding logistics? Any suggestions or research work in this field? Yes, when it is coming to the logistics, I told that the trip generations, I have shown the four-stage model. The four-stage model is not only with respect to the passenger movement, also it is a goods movement. So for transferring the goods, transportation's logistic is playing the major role. You can study about the how the number of the trips are generated, different kind of the trucks are there with respect to the axle load, how the mode choices are happen or the split are happen, that can be studied. Then the next will be, nowadays the people are encouraging the online delivery. So most of the people are now it is going with the online delivery. Due to that, how the logistics trips are increased, how it is influencing the transportation pattern, that can be studied when it is coming to the logistics. So these are the some of the research you can focus with respect to the trip generations in the aspect of the general truck, or when it is specifying the online delivery. So you can narrow down your research also. So next will be how civil engineering is related to soft computing techniques. Yes, definitely civil engineering is related. Engineering itself, it is related to the mathematics. So when it is coming to the mathematicals, it is an old day to sit and solve all the mathematical issues. Nowadays, we have the various attractive and the fast forward solutions that can be solved using various soft computing techniques. So it is linking each other. So example, the way I have shown in the transportation engineering, how the mathematics is playing the major role to solve that mathematical issues, how the soft computing methods can be linked. So it is a linking process, I'm sure. So soft computing is playing the major role, and I'm sure that it is playing the major role for other specializations also, structural engineering as well as the geotechnical. So during the STTP, definitely you come to know, since it is in a first day STTP, so this kind of the question is arising. But end of this wonderful STTP sessions, so you come to know the solutions for your particular question. So any other question? Which area useful in research in transportation? So this questions, not every research has a useful. So whatever the research you are choosing, so it should be applicable on the field. So when it is coming to the transportations, we are playing with a human. So whatever the solutions you are trying to provide, at the end, the road users going to utilize that particular solutions. So with that applications oriented, whether if you are targeting the successful solutions, then definitely the project, it will be worthy one, irrespective of the payment engineering, traffic engineering, or the transportations planning. Okay, so all the projects has an equal usefulness, but the priority may change with respect to the conditions. So now when we are talking about the COVID-19, that definitely the transportation system is going to get an influence. To study that influencing or the impact, and what kind of the planning process or the policies we can provide, so that become a now the hot topic. So that will be the trends may be changed, but the usefulness when you're targeting, that will be equal to all the field. So any other questions? So web is used for soft computing. I'm sorry to say that I'm not aware of that web actually. So maybe you just explore in that online, or definitely you will get in solutions for that further STTP with other expert.
That's fine, sir. I think that's all about for today's session. Yes, sir. Yeah, we'll close the session. So thank you so much for accepting our invitation from the Department of Civil Engineering and Civil Engineering. Is thanking you very much for taking part of this AICTE program. We look forward for more collaborations in the future.
Okay, thank you, Dr. Girish. Thank you for the opportunities. Okay.
MATLAB application in soft computing. So can you address this question? Someone is asking about the MATLAB.
MATLAB applications in soft computing. Yes, MATLAB, it is there. In the MATLAB, you can able to perform the ANN, artificial neural network. Even you have the fuzzy logic, you can able to solve that MATLAB. Okay, so that is also can be performed. In case if you want to perform the optimizations, genetic algorithms, so you have the applications with that MATLAB. So yes, MATLAB is one of the best and most widely used platform to solve all the soft computing problems.
Yeah, all right, sir. Yeah, thank you, sir. Now we can, yeah, we'll close the session. Thank you, sir. Thank you very much. We look forward to future collaboration.
Thank you, everyone. Yeah.
All right.
So I'm leaving the session, Dr. Girish.
Yes, sir. Please, sir. Go ahead. Thank you, sir. Thank you for your time, valuable time, and patience for clearing the doubts. Thank you.
Yeah, thank you.
So I request all the participants to go to the link which is given. Feedback you can provide using the link which is provided in the chat box. So that's all about for today's sessions, both from morning and afternoon. We will come back with tomorrow's by sharp at 10 o'clock we'll have a session with Professor Ello, who is the head of the department of IIT Bombay, Surgery Department. So we will be having a very nice session tomorrow. I'll once again post it. I'll post this. Yeah, it is posted again, so you can use the link if someone is missing to give your feedback. I'll open this for session for 1 more minute. So whoever is not able to give feedback can give it to this link. And I thank all the participants for your participation and patience through the session. I request all of you to come back again tomorrow morning at 10 a.m. for having another session as a part of this AICTE sponsored workshop. Morning attendance link I can share through mail. Please mail us if anybody is missing today's morning feedback. So you can just request us through email. I'll post email. I hope that you are having the email to you. But still, I'll post my email ID so that you can request.
Sir, morning attendance link.
Yeah. Now here I cannot share, sir. I'll definitely share through mail, sir. Thank you. Yeah, thank you, sir. Thank you. Yeah, sure. We will share that to that respective email. No issue. Thank you. So with this, I would like to end the session. Thanks to each and every participant, each and every professor and faculty. Yeah, I understand, sir. I understand, Naveen Kumar, sir. I will definitely send you through email. Thank you. Yes, definitely. We will send the Sundaram, sir. We will send issues. Yeah, thank you. I'm closing the session. We'll meet tomorrow at sharp 10 a.m. Thank you. Signing off for today.